This is number 39 in lesson 4-6, where we're asked to solve the equation, obviously for n, and so what we want to do is find what the least common denominator would be. Now, what's unique about this one is that this denominator factors down to 3 times the quantity n minus 6. So clearly what we have as unique pieces of our least common denominator, we need an n minus 1. We need a 3, and in addition to that, we need an n minus 6. So we're going to go through and we're going to multiply every numerator by 3 times the quantity n minus 1 times the quantity n minus 6. Every single numerator. 3 times the quantity n minus 1 times the quantity n minus 6, and the last numerator. 3 times the quantity n minus 1 times the quantity n minus 6. What's going to happen then is with our first fraction, the n minus 1's cancel. With our second fraction, the 3's cancel. And with our third fraction, the 3's cancel and the n minus 6's cancel. So with our first fraction, we will have 3n, the original numerator, times 3 times n minus 6. The n minus 1 canceled. With our second fraction, we'll have n minus 1. Well, actually 1 times n minus 1 times n minus 6. And with our third term, we'll have negative 40 times n minus 1. The 3 and n minus 6 canceled. So now we'll distribute. This, of course, is 9n. 9n times n is 9n squared. And 9n times negative 6 is negative 72n. Oh, sorry. 9n times 6 is negative 54n. Minus, I'm going to FOIL this, but put my answer in parentheses to remind myself that everything needs to be subtracted. First times first is n squared. Outside times outside is negative 6n. Inside times inside is negative 1n. And last times last is positive 6. On the right side of my equal sign, I'll have, when I distribute, negative 40n. And negative 40 times negative 1 is positive 40. All right, now my like terms. 9n squared minus 1n squared is 8n squared. Negative 54n minus negative 6n is the same as negative 54n plus 6n. A double negative makes it positive. Negative 54n plus 6n is negative 48n. And then what we have remaining is minus 6. On the right side, negative 40n plus 40 cannot be combined. So clearly this is quadratic because we can see that our highest degree of any variable is 2. So to solve a quadratic equation, we need to get it equal to 0. So I'll bring everything over to the left side of the equal sign. I'll have to add 40n to both sides, which gives me negative 8n on the left. And I'll have to subtract 40 from both sides, which will give me negative 46 on the left. And 0 on the right. I discovered an arithmetic error here. I had, in the green, I had negative 54n minus negative 6n does add up to negative 48n, but then I also had minus a negative 1n. That's plus 1n, so this should be a minus 47n. All right, so then what happens is then 8n squared, if I add 40n to both sides, I get negative 7n, And then if I add or subtract 40 from both sides, I get negative 46. Sorry, I forgot to hit record. So now I have a quadratic equation and I want to solve for the variable. And clearly I have quite large numbers to work with here, so probably the easiest way to solve this one would be to use the quadratic formula. I'm going to find the value of the discriminant first, b squared minus 4a squared, or 4ac, excuse me. B squared would be negative 7 squared, which is clearly 49. 4 times a times c would be 4 times 8 times negative 46, which would be minus negative 1472. Again, I have a double negative, which makes it a positive, and that in turn results in us having 49 plus 1,472, which is 1,521. So the quadratic formula says take the opposite of b. Well, b is negative 7, so the opposite of negative 7 is positive 7, plus or minus the square root of the discriminant, which nicely I'm going to find is a nice whole number, all over 2a, which would be 2 times 8, which is 16. The square root of 1,521 is 39. So I have 7 plus or minus 39 all over 16. If I take 7 plus 39, I get 46. 46 over 16 reduces to 23 over 8. If I use the minus, 7 minus 39 is negative 32. Negative 32 over 16 is negative 2. Those are my two solutions. If I plug them into the original equation, I'll find out that the two sides do in fact come out equal to one another.